All right, so we are live again. So I welcome all of you back to this amazing platform, Tutee Learning. I hope I'm audible to all of you, right? So welcome back to this amazing platform, Tutee Learning. And today, let us continue our discussion on Parabola, right? So we have been discussing with Parabola for quite a long time now. Now it is a lecture number 5 for Parabola. And in the last class, we have been discussing with the questions on tangents of a parabola, right? And with that, we left over here when we were discussing about the or how to write down the equation of a common tangent, right? This was the point where we left in our last class, right? I hope you have understood the concept of tangent in the last class, right? Please let me know in the live chat, yes or no. Okay, is the concept of tangents clear to all of you? Do let me know in the live chat. Okay, so and if you're new to this particular platform and you're wondering what is going on, then let me tell you that this particular contents are basically targeting for all the students who are currently in class 11th and 12th and are starting to their preparation on their JEE mains and advanced examination. Okay, so if you are in class 11, this content is going to help you a lot, and also if you are in class 12, this content is going to help you out in form of some revisions, right? Because your JEE mains is very near, and I think this kind of content is going to help you a lot, especially when you are revising, right? So with this particular thing, let's get started, and please do watch the previous lecture before you start to watch this current lectures, right? So with this particular note, let's get started, right? So in the previous lecture, we have been discussing with the equation of the tangent, right? So and we left over here with the discussion on the common tangent, right? So I discussed briefly in the last class that try to write the equation of the tangent to this particular standard parabola in the slope format. So if you write down the equation of the tangent in the slope format, that is going to be y is equal to mx plus a upon m. And now if this particular line has to be a slope, now if this particular line has to be a slope to this particular parabola, which is given as x square is equals to 4ay. So for this parabola, if this particular line 1 has to be a slope, then the solution of this equation 1 and this equation 2 should have only one solution. That means if I try to solve equation 1 and equation 2, the quadratic equation I will obtain will have only one root, that is the discriminant of that particular obtained quadratic should be equals to 0, right? So let us try to do that in the following manner, right? So if I so in the equation number 2, if I substitute for y, so I'm going to get it as mx plus a upon m, right? So if I'm putting it over here, and then if I simplify, this result is going to look like 16 times a square m square is equals to minus of 16 times of a square upon m, right? So this is going to be this is going to be the discriminant, right? So from this particular quadratic equation in x, the discriminant should be equals to 0, which is basically this particular expression, right? Which is this particular expression over here, right? So this is the expression for discriminant equal to 0, and if I solve it further, what I will obtain over here is that the value of this common tangent will turn out to be minus of 1, right? So therefore I can easily write the equation of the common tangent by putting m is equal to minus of 1 over here. That is going to come out as x plus y plus of a is equals to 0, right? So this is how the equation of the common tangent is going to look like, right? So I hope this particular question was clear to all of you, because this is a pretty simple problem. So in whenever questions of common tangents are basically being asked, what you will do is that the treatment is very simple. So try to write down the equation of the tangent in the slope form to first curve and try to satisfy the criteria of tangent to the other curve, and in that manner you can easily obtain the slope of the common tangent, right? So that is the method to utilize or to understand when we solve for questions. Okay, now let us move forward with discussion about one more important problem which I feel is very important, especially for your JEE mains examination, right? So these kinds of problems are very much likely to be asked in your JEE mains paper. So therefore, let us try to discuss on this problem. Okay, that is the question on shortest distance, right? So in this question, if you read it carefully, it is being asked to find out the shortest distance between the line y is equal to x minus 2 and the parabola y equals x square plus 3x plus 2, right? So let us try to solve this problem, and this problem is a very important problem, especially for your JEE mains paper, right? So these kinds of problems are some problems where you have to understand the geometry in order to deal with the shortest distance, right? So let us try to analyze and see over here how we will proceed to the solution of this problem. Okay. So first of all, let me try to draw the situation as possible over here. So we have this parabola which is basically given as, sorry, y equals x square plus 3x plus of 2, right? So y equals x square plus 3x plus of 2, that is the equation of the parabola, right? And the line equation is given as, y is equal to x minus 2, right? So this is the equation of the parabola, and this is the equation of the line, right, which we have with us. So if I try to draw the parabola, first of all, now this parabola is having root at x equals minus 2 and minus 1. So this is going to look like something like this, right? I hope this is clear to all of you, right? So this particular parabola is going to look like this, and let us try to draw the line over here, right? So the line equation, that is y is equal to x minus 2, is going to something like this, right? Where this y-intercept is basically minus of 2. Okay, so I hope this is clear. Is this part clear? Right. Now from here, in order to find out the minimum distance of this particular parabola with this line, let us call this line as L, and the parabola is given as some S, let us say S, right? So if I want to find out the shortest distance, then the shortest distance will be such distance that if I take up any point P on the parabola, and if I draw a perpendicular line on this line, this particular distance has to be the minimum distance, right? So in order how to ensure that this particular distance will be the minimum distance. So the easiest way is to ensure the distance is going to be minimum is that I will have the tangent at this particular point P to the parabola will be basically being parallel to this particular line over here. So if I draw a tangent at point P, let us call the point P as some x1, y1, and the tangent at point P should be parallel to this line over here. And in this manner only, I can get the minimum distance between the parabola and the line, right? So this is a very important concept that you need to understand and keep in mind whenever you are solving any such questions of shortest distance, okay? So this question of shortest distance is very, very important, especially in times of geometry, when you have to visualize it by geometry and then you have to solve for the answer, right? So in this manner, you can easily utilize this problem and you can solve it very quickly, because the slope of this line is basically equals to 1. There means the slope of the tangent at point P should be also equal to 1, right? So slope of tangent at point P, right? So the tangent at point P should also be equals to 1, right? Now, and we know that from the equation of tangent in the slope format, we know that it is basically given as y equals mx plus a upon m, right? Now this kind of parabola, there is an concept over here. Now in order to do with this kind of parabola, which is not very standard, let me use a differentiation approach, right? So dy dx at this point P will be the slope of the tangent at point P, and that can be given as, so if I differentiate this expression, it will be equals to 2x plus 3, and let us, since P is basically x1 comma y1, so it is 2x1, and that is equals to 1, right? So from here I can easily obtain my x1, which will turn out to be minus of 1, and if I put x1 equals to minus of 1, my y will turn out to be 0, right? So therefore this point P is something over here, which is minus 1 comma 0, right? Therefore the minimum distance of this parabola from the line is going to be this particular perpendicular distance, right? And if I try to find out this perpendicular distance, which will be the shortest distance, so the shortest distance is going to be d minimum, which is the perpendicular distance of this point P on this line, which will turn out to be 3 upon root 2, right? So if you solve it, it is going to come out as 3 upon root 2 units. Is this part clear? Is this part clear to all of you? Is this part clear to all of you? Okay, so this is a very important concept that you need to keep in mind when you go on further with solving questions, okay? Because these kinds of problems are very crucial, especially for your JEE mains paper, right? So please keep this in mind. It is not only true that these kinds of problems will be only there in parabolas, especially. However, you can encounter this kind of problem, especially in other chapters like ellipse, hyperbola, right? So please take this concept in mind, especially also in chapters of complex numbers, right? So where you will be given the complex number expression, which is basically representing a geometry, will be given, and you have to find out the shortest distance or the minimum of the modulus value of z1 minus z2. In this case also you can utilize this particular concept and we can try to solve problems, right? And those kind of problems we'll definitely try to utilize and see in our further discussion on complex number, right? So once we finish up with coordinate geometry, I'm definitely going to start very soon with the algebra portion, right? And we're going to begin with in algebra with matrices and determinants, right? Because my target is basically to cater all the important chapters and also to make sure that whoever is appearing for this particular JEE mains paper that is going to happen in the January attempt, I think he has or he or she definitely needs to get the high weightage chapters to be done first of all, right? So that's why when we start with algebra, we are definitely going to start with matrices and determinants, right? So all this particular thing is clear. Then let's proceed with our next discussion. Okay, so let us try to discuss about some more problems, and we will also see some more problems, and definitely we'll try to give some homework as well, right? But let us quickly discuss about some of the important properties regarding the tangents, right? So the properties of tangent. So properties of tangents. Okay, so let us discuss about the properties of tangents. Okay, so let us discuss about the properties of the tangent. So the very first and the important property of tangent is that the point of intersection of tangent at any 2 points on the parabola is going to be, so let us try to discuss about the point of intersection of tangents at any 2 points, okay, and what is that particular point of intersection, okay. So let us try to discuss about the point of intersection of tangents at any 2 point, okay, at any 2 points. Okay, so what is happen that whenever we have two tangents at 2 points drawn, and what will be the point of intersection of that, and is it a fixed point or not, or how do we determine that particular point of intersection? Let us try to analyze that particular result, right? And why am I discussing this in our properties? Because we will definitely try to see in our upcoming question that the point of intersection of tangents at 2 points is a very useful question, okay. So therefore let us try to discuss about this particular thing right now. Okay, so let us take up the standard parabola again. So let us have with our standard parabola, let us take the standard parabola, that is y square is equals to 4ax, right? And if I take up 2 points, let us say the 2 points are something like point P, which is given in terms of parameter t1, and let us take point Q, which is given in terms of parameter t2, right? And if I try to draw a tangent to point P, something like this, and tangent to point Q, something like this, then this point, these two tangents are intersecting at some common point that is given as R. Okay, let us call it R, right? And we'll see that this particular point R is going to have the coordinate as a times of t1 t2 comma a times of t1 plus of t2, right? So this is how the coordinate of point R is going to look like. All right, so let us try to see that how we can come across this particular result, right? Now, it is very simple to derive it, that we can easily write the equation of the tangent in the parametric form for this point P, and that will turn out to be t1y is equals to x plus a t1 square, right? In the similar manner, the tangent for point Q will be given as t2y is equals to x plus a t2 square, right? And if I solve for this two equation, if I solve for this two tangent equation, and you can easily obtain the point of coordinate or the point of intersections of this particular two tangents, right? So you can, it can be easily solved out. If you just subtract these two equations, the x will get cancelled out and you will left out with y part over here, right? So you can easily get y, and from y you can easily get x, right? And you will see that this particular result holds true. Okay, so the coordinate of r is given as a times of t1 t2 comma a times of t1 plus t2. Now it is interesting to know that this particular result, that y x coordinate, is basically the geometric mean. Okay, so this x coordinate is the geometric mean of the point P, which can be given as at square comma 281, and point Q, which is given as a t2 square comma 2a t2, right? So if you take the geometric mean of the x coordinate of first 2 points, you will end up getting a times t1 t2, and this y coordinate is basically the arithmetic mean of the y coordinate of P and Q, right? So this is how we obtain this following point of intersection. So that is a very important property that we need to keep in mind when we are going to solve questions. Okay, so this is a very interesting thing that you will observe, that in the case of parabola we'll have this particular thing holds true. Okay, I hope this is clear to all of you. I hope this is clear. Is this part clear? Hi King, is this part clear? Okay, so let us now discuss about what happens if I take 2 points on the parabola, or if I want to find the locus of foot of perpendicular from focus upon any tangent. Is a tangent and the vertex, like, is it true or not? Let us try to see it, right? So what I'm trying to say is that for a given parabola, so let me write it down. This is my second properties that I'm discussing about, that if I try to draw a, let us take the standard parabola to start with. So if I draw a parabola like this, which is y squared is equal to 4ax, y squared is equal to 4ax, and if I draw the uh, foot of perpendicular from the tangent, or if I draw any tangent to this particular parabola over here, let us say this tangent is drawn at point P, which is given as at square comma 2at, and so what I'm trying to find it out is that I'm trying to find out the locus of foot of perpendicular from focus upon any tangent is the tangent at vertex. Okay, so if I now take up the foot of perpendicular, so this is the locus over here of this particular parabola. Now if I draw a foot of perpendicular on this particular tangent at point P, then this is definitely going to be, so all this set of Q, so if this is point Q, now if I represent this point Q as h comma k, the locus of this h comma k is the tangent at the vertex, that is basically 0 comma 0, right? So this is what we need to prove over here, right? So how can we do that? So what I'm trying to say is that I'm trying to find out the locus of foot of perpendicular from the focus to the any tangent. Okay, from focus, which is basically a comma 0 to any tangent. Okay, to any tangent, and let us try to see that what is the locus going to look like. And we have definitely discussed that this locus is basically the tangent at the vertex, that is 0 comma 0, right? So if I try to discuss about this particular scenario, so if I draw any since this is foot of perpendicular, so therefore the slope of this line SQ is given as, the slope of the line SQ is simply given as at minus 0, because this particular point is going to be 80, 0 comma 80, right? Which you can easily obtain because you know the tangent equation is basically Ty is equals to x plus at square, right? So you put x equals to 0, you will get the value of y to be coming out as 80. So 0 comma 80 is the coordinate of the point Q, and if I try to find out the slope of the SQ from this coordinate, that is 80 minus 0 divided by 0 minus a, and this will turn out to be minus of t, right? In the similar manner, so therefore the slope of the tangent, that is PQ, is going to be the since it is a perpendicular line, so this will be going to be equal to 1 upon t. This will be equals to 1 upon t, right? So the slope of the tangent at point P is given as 1 upon t. Now in this form we can definitely say that since SQ is perpendicular, and we already know that at any given point of a parabola the slope of the tangent is always equals to 1 upon t, right? So that means that if I draw a foot of perpendicular to the tangent, to any tangent to a parabola, it is definitely going to intersect at the point where the x coordinate is equal to 0. That means it is the point where the tangent at the, or this is basically the y-axis, right? Or y-axis is nothing but the tangent at the vertex. Alright, so this is not only true for the standard parabola, however, it is also true for any set of parabola as well. Is this part clear? Is this part clear? Okay, so this is a very important relation we need to keep it in mind. Okay. Okay, so we'll definitely see some more properties regarding this as well, right? And another important property to be noted is that if I, there is a third property, right? So that this property talks about that if I have a standard parabola, so this is my standard parabola, and like this. Now the length of the tangent between the point of contact, so if I take up, let us say P is my point of contact, which is given as 80 square comma 280. This is my point where the tangent is drawn. Let us take this point, and the point where this tangent intersect the directrix is given as point Q. So the length of the tangent between P and Q, or the point of contact and the point where it meets the directrix, is subtending a right angle at the focus. So this particular angle at the focus is going to be equal to 90 degree, right? So this particular angle is always equals to 90 degree, right? So it's a very important relation that we need to keep in mind. So the length of the tangent between the point of contact and the point of the tangent intersects the directrix is subtending a right angle at the focus. I hope this is clear to all of you. Now we can easily prove this particular result by applying the concept of, so we can find out the equation of the line PS, and we can also find out the slope of the, or the slope of the line PS and the slope of the line SQ, right? And then if you multiply, you will find out it is going to be minus of 1, right, or negative 1. And with that, it proves that the length of the tangent segment, or the tangent segment within the point of contact of the parabola and the point where the tangent intersects the directrix is going to subtend a right angle at the focus. Okay, is this part clear? Is this part clear? नमन राज, कॉम्प्लेक्स नंबर पढ़ाओ. कॉम्प्लेक्स नंबर पढ़ाऊंगा. ओके, ये खत्म तो कर लेने दो. नमन राज, आपका इशू डेफिनेटली हो जाएगा, ठीक है, कवर हो जाएगा, कॉम्प्लेक्स नंबर पढ़ा दूंगा, ठीक है. Is this part clear? Okay, and another important results also to be kept in mind, that is, so that is the fourth property. Okay, and this property says that if I again have a standard parabola, if I have any parabola like this, or let us take the standard parabola. Now if I draw tangents from the extremities of the focal chord, so let us say this S is my focus and this is the endpoints of the focal chord, that is P and Q, and if I draw the for tangents at the focal chord, or the extremities of the focal chord, if I draw tangents at the extremities of the focal chord, right, then this particular intersection, or the point of intersection of the tangents at the extremes of the focal chord is definitely going to subtend an angle of 90 degree at the point where it intersects the directrix. Okay, so the tangent at the extremities of the focal chord are perpendicular, and so therefore they are perpendicular and they always intersect at the directrix, right? So this is my equation of the director circle, right? So if you recall, in the concept of director circle, we have mentioned that director circle is the locus of the perpendicular intersection of the tangents. Okay, so perpendicular tangents, wherever two tangents are perpendicular to each other and they intersect, that particular locus is basically the director circle, right? So in the case of the parabola, the director circle is basically a simple straight line, which is the directrix, right? So please keep this in mind, because this is going to be a very important question, that find out the locus of the perpendicular intersection of the tangents at 2 points, right, for the given parabola, and that is the director circle, and that is nothing but the directrix, that is x plus a equals to 0, right? As simple as that. Okay, so let me write it over here. So x equals to minus of a is the equation, the directrix or the director circle for a parabola. Okay, I hope this is clear to all of you. Is this part clear to all of you? Is this part clear? Okay, so our next topic is definitely to discuss about the equation of normals, right? So now as we are done with the equation of tangent, let us now go into discussion of equation of normal, right? So in case of circle, the normal was simply a straight line passing the center, because all the line or the points or the radius is always perpendicular to the tangent, right? But in case of hyperbola, the normal, there can be scope of drawing three normals at a given point of a hyperbola, right? Let us see how we can do that, right? So if I take the simple parabola, so let us take, this is our parabola. So at any point P, which is given as x comma y, and as we know that normals are nothing but perpendicular to the tangents, right? So this is how the normal would look like, the perpendicular to the tangents, right? So this is how the normal would look like. Now as we have, let us take the simple case of the standard parabola, which is y square is equal to 4ax, and if I differentiate this expression with respect to x, we get this as follows, and from here I can easily obtain dy by dx at point P will definitely give me the slope of the tangent, right? So at point P, it is definitely going to give me the slope of the tangent, right? Now we also know that since normals are perpendicular tangent, so from the slope of the tangent we can obtain the slope of the normal. So slope of the normal is going to be minus of 1 upon slope of the tangent, and that is going to come out as minus of y upon 2a. So at any point P on the parabola, the slope of the normal is given as y minus of y upon 2a, right? So in a similar manner, we can easily write down from here the equation of normal to a given parabola at point P can be easily given as y minus, let us say this point P is y1 x1, or sorry, x1 y1. So y minus y1 is equals to slope times, so minus of y1 by 2a multiplied with x minus x1. So if I simplify this particular part, this is how the equation of a normal to a given parabola is going to look like, right? So this is how we write down the equation of a normal to a parabola, right? And a similar approach, we can also do the parametric form, or the parametric representation of the normal is that, so any parametric form of a parabola can be given as 80 square comma 280 for the standard parabola, and therefore if I do it and put it over here and I simplify, the result for the equation of the normal is going to come out as y equals minus of tx plus 280 plus 80 cube, right? This is how the equation of the normal is going to. So please take this thing in mind. So please take this in mind, that the equation of the normal in the parametric form is going to look like this. Okay, so which is very simple to obtain over here. And in a similar manner, again, if you relate it with the equation of the slope format, so from the slope, it is very simple that t will be the slope of the normal. So minus of t is the slope of the normal. So that is going to be equal to m, right? So if I try to write down this particular thing in the slope format, so this same equation can be written as y is equal to mx minus 2am minus am cube. Okay, so this is how the equation of the normal in the slope format going to look like. Okay, so these are the three different forms of the equation of normal that we have for a given parabola. Is this part clear to all of you? Why don't you join any institute? You become famous and leave it. Ajay Jain, hi. Naman Raj, are you Bengali? Yes, I'm a Bengali. Okay. Naman Raj, I'm working on my own institute. You can see, right? I don't need to join any institute. Okay. Is this part clear to all of you? Okay. So we are definitely going to solve problems on normal in our upcoming lecture. But before I end the today's lecture, I want to also show you that how the equation of normal would look like for all the three different or all the other form of standard parabolas, right? So let me show you that how the equation of a normal would vary for a for other sets of standard parabolas, right? So this is how we're going to have the equation of normals to the parabolas for the other set of forms, right? So for the parabola whose axis is the x-axis and the y-axis, so if you change it, then how the equation is going to look like is all what we have to take in mind. Okay, so don't worry about this particular results to be remembered very difficult. Okay, so it is very simple to remember. Just keep on solving some problems. Okay, the base case you have to remember is this particular case. Okay, so you have to remember only this particular case, and from this particular case you can definitely go on to solve any problems, right? And even if you forget in the examination hall, it is always very simple to derive it by just simple differentiation. Okay, so please take the basic things in mind so that whenever you forget up stuffs in your examination, you can definitely derive it easily by few steps, and you can definitely jump on to getting to the answer. Okay, so final answer, right? Is this part clear? Is this clear to all of you? Do you have any questions? You can let me know. Okay. Okay, so now what I'm going to do is that I'm going to give you some problems to practice as a homo problems. Okay, so take some problems and try to solve it up. Okay, so I'm giving some homo problems to solve. So please take your time and try to solve this problem, and do let me know the answers you are getting. Okay, we can definitely discuss if you are unable to solve any of these problems. Okay, so please try your best. Okay, just give a try. These are the 7 problems that you need to discuss, or that are very useful in order to understand the concept of tangents. Okay, so these are questions are basically the tangents to a parabola. Okay, so tangent to a parabola is basically the main things that you need to discuss in this particular questions. Okay, so please try to solve this problem, and if you're unable to solve any of these problems, do let me know in the comment section. I can definitely discuss about these solutions as well, right? So I hope this things is clear to all of you, and with this part let us end our session today. And we have been discussing with the parabola. Okay, is this part clear? Right, so please try to solve this problem, take a screenshot of it and try to solve it up in your as a homework problems. Okay, and we shall discuss upon this question in our next class. Okay, so till then I wish you all the best, and I thank you for your wonderful attention to this particular lecture, and I hope to see you soon in our next live class. Okay, so till then, okay, bye, take care, and also hit the like button to help us contribute, and also let us know that whether you enjoyed these lectures or not, and what all else or different things you want to basically see on this particular platform as well, right? And we are definitely going to start with our JEE mains one shot revision session, which is going to come live very soon on this particular platform. Okay, so if you're new to this particular platform, please subscribe and also hit the bell icon so that you don't miss out any upcoming notification from this particular content, so that whenever we are live, you directly get the notification and you can attend the and join the class. Okay, so with all these things, let's end our class over here, and I see you soon in our next day. Okay, thank you.